I'll talk about a few terms and definitions which look very close, but yet there are differences in their interpretation. And you have to understand what is the meaning of all these three terminologies: review, verification, and validation. What is a review? Review is actually determination of suitability, adequacy, and effectiveness of an object to achieve its established objective. That's how ISO defines. Now, let me explain this with an example. We do design review or document review. What we do, we check whether this document or the drawing is suitable to achieve its objective, whether the calculations and all other things that is needed to make this product is correct or not. So it's a determination of suitability. It could be design review or calculation, review of the calculation. And when we talk about review, there is an interdepartmental or interfunctional involvement. A crane design is reviewed for structural integrity, for example. The design is made in such a way that is strong enough, but this is not so easy to weld. Some of the components orientation may have to be changed for higher productivity. So when we do a review, we check calculation, design from, say, structural integrity point of view, ability to make an assembly properly, or things like that. Sometimes the review can be done from handling and transportation point of view. You have made a huge structure which is suitable from structural integrity. You can manufacture, but the space is very difficult to maneuver it and handle it and transport and deliver. So when interdepartmental involvements are happening from different usability perspective, we can call it as a review. So determination of suitability, adequacy, or effectiveness of an object of a product to achieve its established objective is review. Design review, document review, this is what we do. Now, verification is confirmation process through provision of objective evidence. So you have to get some evidence that a specified requirement has been fulfilled. In other words, design verification. So when we perform a design verification, for example, you check whether all the inputs as necessary were considered to get the right output. For example, customers specified their own standard requirement to be followed for designing the vessel. They also refer the latest version of ASME codes and standards to be followed. So in the verification, what is done is that we check whether the necessary inputs were taken from the contract document, from the client standard, as well as the ASME standards. So once these are done, the output is going to be acceptable. So the verification process, you actually check inputs, outputs, whether all the necessary informations have been considered or not. In other words, if the product is manufactured in accordance with these design calculations, with these drawings, it will meet the intended purpose or the client's requirement. So verification is confirmation through provision of objective evidence that a specified requirement has been fulfilled. Let me give you an example with a pressure vessel, and that will make your understanding very clear. Say the requirement for a pressure vessel is that the length of the vessel should be, say, 10 meter, 1 meter diameter, carbon steel 516 grade 70, and it will have internal coating, it will have cathodic protection system, and externally epoxy painting with white color paint. Saddle supports and equally spaced from the center at 8 meter gap in between, distance in between. The nozzle orientation should be like this, whatever is given as per the customer requirement. The addition shall be, ellipsoidal or whatever design the designer chooses or the customer requires. And the minimum thickness should be this much. There has to be baffles inside the separator plates. Baffle plate should be like this. Let's consider these are the requirements from the customer. Now, this has been designed and the drawings have been made by design and development team. So, at the time of verification, what you look at is this was the requirement by the customer. Is the drawing meets that requirement? Is the saddle supports are properly spaced as a requirement of the customer? If it is not, maybe the foundation for the saddle supports is made by another contractor. So once it goes, the saddle support, if not spacing properly, then it will not sit on the foundation. So, and the additions and the nozzle orientations, because the piping connection which can be done by some other company. So if the nozzle orientations are not done exactly in accordance with the requirement of the customer, then it will not meet the end user requirement. Therefore, while you do the verification, it's like a cross-checking process that all the input requirement or the output requirements have been complied with or have been met. So if the object is manufactured or produced, it will meet that requirement. That's basically verification. So one thing is important. The verification and review can be done at the same time. It is not that at the time of verification, review cannot be done, or at the time of review, verification cannot be done. But there is an interdepartmental or interfunctional involvement in the review process because you look at different aspects of the product, things like that. So this is what is the importance of verification and review. As I said, it can be done by the same person at the same time, can be done by different person at different time. Now we'll talk about validation. Validation is confirmation through provision of objective evidence. Up to this, verification and validation look same. But the difference comes from here that the requirement for a specific intended use or application have been fulfilled. In other words, the design intent is now fulfilled. So the pressure vessel was designed with whatever requirement. It is supposed to work at say 15 bar or 20 bar pressure. Now by hydro test, you have seen that the pressure, the vessel is suitable and it can withstand the pressure of 20 bar or whatever is requirement. It is suitable for the intended purpose by actual test. So when we perform validation of a crane, we do proof load testing. When a car picks up the top speed at certain period of time, we say within 1 minute it could achieve this speed. The maximum speed validation, the vehicle is supposed to take in ideal conditions, say 240 kilometer per hour. So can it really take that speed? That's the validation. A crane can lift the rated weight is validation. So validation is always by actual test or kind of evidence that the intended purpose is fulfilled. Crushing strength of the cubes, concrete cubes, once you are doing, you validate that yes, this concrete casting design, mixed design, if you are making a slab casting with this mixed design, you have validated the process by crushing strength or compressive strength that this much compressive strength is achieved within 21 days. These are called validation. So validation is always by actual test.